Video, we're going to just look at a few examples of using the definition of the derivative to find the derivative of a function and then to plug in a particular point to find the derivative at that value. So there are 4 problems below. I'd like you to give them a try. And you're using the definition of the derivative that f prime of x is the limit as h approaches 0 of f of x plus h minus f of x over h. So give those a try, pause, and I will talk about them one by one. Okay, in our first example, f of x is 4x minus 3. So we're taking the limit as h goes to 0 of 4 times x plus h minus 3 minus 4x minus 3. So the first expression, the first part is f of x plus h minus f of x, all divided by h. Now we just need to simplify this. This is the limit as h approaches 0 of 4x plus 4h minus 3 minus 4x minus a negative 3, so plus 3 divided by h. Now we can cancel out 4x with negative 4x and negative 3 with positive 3, and we're left with the limit as h approaches 0 of 4h divided by h. The h's cancel, and so we've got the limit as h approaches 0 of just 4, which of course is 4. So that is f prime of x. The derivative of the function 4x minus 3 is the function f of x equals 4, a constant function. And so if we want to find f prime of 6, well, f prime of anything is 4. Just the function is the constant function 4, so no matter what the input is, the output is always 4. Okay, now we've got g of x is equal to 1 over x minus 2. So the derivative g prime of x is equal to the limit as h approaches 0 of 1 over g of x plus h, that's x plus h minus 2, minus g of x, that's 1 over x minus 2, all divided by h. So now we want to somehow simplify this, get rid of the h in the denominator. So one thing we can do is try to combine those fractions by finding a common denominator. So this is the limit as h goes to 0 of 1 over x plus h minus 2, and I'm going to give some space, minus 1 over x minus 2, all divided by h. And to get a common denominator, I'm going to multiply each of those by the denominator of the other fraction on the top and bottom. So x minus 2, x minus 2. And over here I'm multiplying by x plus h minus 2 and x plus h minus 2. And so now I can simplify that or distribute. I've got the limit as h goes to 0 of x minus 2 is the first numerator, and because they both have the same denominator of x plus h minus 2 times x minus 2 now, I can combine them into a single fraction. So that's x minus 2 minus x plus h minus 2. And so let's see what simplifies now. I've got an x and a negative x, and I've got a negative 2 and a negative 2, so a positive 2. So those cancel out with each other. And what have I got left? I've got, this was all divided by h. Sorry about that. So this is now the limit as h goes to 0 of, in my numerator, all I've got left is a negative h, and then x plus h minus 2 times x minus 2, all divided by h. So I've got h over something divided by h. My h's cancel out. And so this is the limit as h approaches 0 of negative 1 divided by x plus h minus 2 times x minus 2. And now I can plug in my h equals 0, limit as h approaches 0. because the denominator will no longer be 0 at that point. So this is negative 1 over x plus 0 minus 2 times x minus 2, or just negative 1 over x minus 2 squared. So that is my derivative g prime of x. And we were asked to find g prime of 0. That's negative 1 divided by 0 minus 2 squared. So that's negative 1 over negative 2 squared. That would be negative 1/4. Okay, now we've got the function y equals negative 5, just the constant function. So y prime is going to be equal to the limit as h goes to 0 of y evaluated at x plus h minus y evaluated at x, all divided by h. So what is y when it's evaluated at x plus h? Well, the output, no matter what, is negative 5. So this is the limit as h goes to 0 of an output of negative 5 minus y of x. Well, no matter what x is, again, that's a negative 5 again. And that's divided by h. And so we've got the limit as h goes to 0 of 0 over h, and that is just 0. So y prime in general is equal to the constant function 0, and if we're looking for what is y prime evaluated at 1, well, that is 0. Our last example is f of t equals 2 minus t squared. So we've got the limit as h goes to 0 of f of t plus h. So that's 2 minus t plus h squared minus f of t, that's 2 minus t squared, all divided by h. And so that's the limit as h goes to 0 of 2 minus, and then t plus h squared is t squared plus 2th plus h squared. You can do that out separately if you wish. Minus 2 minus a negative, so plus t squared, all divided by h. And now my 2's cancel. I've got a negative t squared plus a t squared, and so this simplifies to the limit as h goes to 0 of, what have I got left? There's a negative out front of those first terms, so negative 2th minus h squared is all that remains in the numerator, divided by h. I can now factor an h out of the numerator, so limit as h goes to 0 of h times negative 2t minus h divided by h. And so now I can cancel an h from the numerator and denominator, reduce that fraction, and I've got the limit as h goes to 0 of negative 2t minus h. And so this just reduces down to limit as h goes to 0, negative 2t. T is not affected by what happens to h, minus 0. And so my solution is negative 2t. So that was f prime of t. F prime of t is negative 2t. And we were asked for f prime of a specific value. We were asked for f prime of 3. So f prime of 3 is negative 2 times 3, that's negative 6. So that is it.